So let's get started with this problem. We're going to have to use the quotient rule. So let me remind you guys what that is. The quotient rule is if you see, this keeps going up, if you see d over dx, or you're taking the derivative of two functions, one being divided by the other here, we're going to have g of x times f prime of x minus f of x times g prime of x over g squared. You might also see that this is equal to y prime, which is what we're actually going to be writing. Let's go ahead and write y prime. Or first, actually, we got to figure out what's our f of x and our g of x, of course. F of x and then g of x. Or f of x is going to be our numerator. So we have x squared times e to the power of x, and then we have g of x is equal to x squared plus e to the power of x. Okay, so now all we have to do is substitute these into our rule here. So we're going to have g of x first, which is just going to be, I don't know if I'm going to have space. You guys think I'm going to have space? Let's go ahead and just write it down below here. We're going to have x, or g of x first, so it's going to be x squared plus e to the power of x. Now we're going to have, so we've written down g of x. Now let's write down the f prime of x. So we have x squared times e of x prime minus the same f of x, x squared times e to the power of x. And then we're going to have, so we've got f of x. Now we're going to have g of x prime. So that's going to be x squared plus e to the power of x prime. And then, of course, over g of x squared, which is going to be x squared plus e to the power of x squared. And, of course, this is equal to y prime. I'm going to write y prime here now. Y prime is equal to, all right, so we don't have to take the derivative of this one here. We just write it down, x squared, write a little bit smaller, x squared plus e to the power of x. And then the derivative of this parentheses here, that's going to be using the product rule now. So we were using the quotient rule. Now we have to use the product rule because there are two things here, x squared and e of x, or e to the power of x, being multiplied by each other. So two different functions that are being multiplied by each other. So we need to use the product rule. So let's go ahead and color code that real quick. We are now going to have f of x, sorry. So the one thing I hate about Apple is that for some reason, sometimes it doesn't erase or it accidentally goes to the eraser. But let's see here. Yeah, it's going to be a lot of work here. So f of x is going to equal to x squared now. And then g of x is going to equal to e to the power of x. So once again, we have to take the product rule of this parentheses here because there's two functions being multiplied by each other, the x squared and the e to the power of x. Okay, so that's going to be f of x, so that's x squared times e to the power of x prime plus e to the power of x, and then x squared prime. That is then going to equal to x squared e to the x. That's the prime of e to the x, just e to the x. So plus, and then times e to the x. And the derivative of x squared is going to be 2x. We have 2x e to the power of x. So that is what we're going to write down here. I'm gonna keep it green for now, but I'm gonna change it afterwards. We just found the derivative of the x squared times e to the power of x. So that is x squared times e to the power of x plus 2x times e to the power of x. So as you can see, we don't have space, so I'm gonna go ahead and continue. I'm not gonna erase anything actually. We're going to move down. We're just going to rewrite this. I know I didn't finish, so we'll go ahead and just put dot, dot, dot. Let me rewrite that. It's going to be x squared plus e to the power of x. Now I'm going to put it in white ink. So x squared e to the power of x plus 2x times e to the power of x. A lot of terms that are being multiplied here. Let me get this microphone down below here so you guys can see me. Okay, so let's see. Now we have to subtract x squared times e to the power of x, and we have to take the derivative of x squared plus e to the power of x. So now we're taking the derivative of this function here, or this parenthesis here. That's just going to be 2x plus e to the power of x. Okay, and we're going to divide all of that by x squared plus e to the power of x squared. All right, now comes the semi-difficult part where a lot of people have their issues with when it comes to these type of problems. It just becomes clustered just the way it is here. The algebra. A lot of people forget to multiply or add the exponents and whatnot. So let's be careful here. We're going to use the distributive property. We're going to do x squared times e to the x. So that's going to be x, was it right? Y prime is equal to x to the fourth times e to the power of x. Now we're going to do x squared times 2x times e to the power of x. That's going to be plus 2x cubed times e to the power of x. So we're done with that. Now we're going to multiply the e to the x here. That's going to be plus. Good thing there's no negative too. We now have e to the x times x squared times e to the x, which is going to be x squared e to the power of 2x, and then e to the x times 2x times e to the x. That's going to be plus 2x e to x, and then we will have to do the same with this one term here, multiplied to the two terms over on this parenthesis. So we're going to distribute the negative as well. So we're going to have negative x, or rather should be, let me erase this real quick. See how it doesn't work sometimes? See how it just, no idea what's going on. I'm literally switching it to eraser and it's not going. So that's going to be negative 2x cube e to the power of x, and then it's going to be minus x squared e to the power of 2x. And that, of course, is going to be over x squared plus e to the power of x squared. And now all we have to do now is combine like terms. So there's no other x to the fourth power, so we're just going to have y prime is equal to x to the fourth power times e to the power of x. So we're done with that. I'm going to cross that out. We have a 2x cubed ex. Do we have another x cubed? Yes, we do. It's actually the same term. One of them is just negative, so they both just cross out. It's going to be 0. Do we have another x squared? We do. Same term over here. One of them is negative, so these could go ahead and cross out. It's going to be 0. And we are left with plus 2x times e to the power of 2x over x squared plus e to the power of x squared. And here we have y prime. Can we factor something out? Yes, we can. We can factor out an x and have x cubed e to the power of x plus 2 times e to the power of 2x over x squared plus e to the power of x squared. Either one of these two right here could be your answer, and that is it. All right, so here's our second problem. We're going to have to do the product rule here, nothing being divided. We have two functions being multiplied, so we're going to use the product rule. That is f of x times g prime of x plus g of x times f prime of x. Let's establish what our f of x is going to be. Our f of x is going to be x squared plus e to the power of x. And our g of x is going to be the root of x, which we can also write down as x to the power of half, or 1/2. All right, so now we'll substitute those values into the rule. We're going to have y prime. We'll say y prime is equal to this. Y prime is, oh, actually, we erased that. All right, so now we'll substitute this into the rule. We have y prime is equal to x squared plus e to the power of x times we'll say x to the power of 1/2 prime plus x to the power of 1/2 times x squared plus e to the power of x prime. All right, so now we'll take the derivative and simplifier. Here we'll just have x squared plus e to the power of x, and the derivative here is going to be half times x to the power of negative 1/2 now, and then plus x to the power of half times 2x plus e to the power of x. So now we've taken the derivative, and we can simplify further by distributing this term over to the two terms over here on the left. So we're going to have y prime is equal to, we can write half x to the power of negative 1/2 times e to the power of x. and then we can have plus half x to the power of negative 1/2 times x squared. And now we will distribute this x to the power of 1/2 over to the two terms on the right. So we're going to have plus x to the power of 1/2 times 2x, and then plus x to the power of 1/2 times e to the power of x. All right, so we can simplify a little further. Many different ways you can show your answer. We can have y prime is equal to, we'll have e to the x. This term is going to change to e to the power of x over 2 times the root of x, okay? And this one over here on the right, go ahead and underline that. It's going to be 2, in the denominator, we're going to have 2 root of x over x squared. Now, we might be able to simplify that much more. So let me change this root x to a x to the power of 1/2. This way I can subtract the exponents. So we'll come back to that one real quick. We'll underline that so we know we have to do some work for that one. Plus x to the power of 1/2 times 2x. This one we'll just add the exponents. So we're going to have 2, and that's going to be to the power of 3 over 2. 1/2 plus 1 is 3 over 2. That's going to be our new exponent for this one. All right, we're done with that. So we're done with that, done with this, done with that. And this one is just going to be plus the root of x times e to the power of x. Okay, so now we're going to be working with simplifying the second term here. We know that y prime is equal to e to the power of x over 2 root x. And this one, we're just going to have to, the second term here, we're just going to subtract 2 minus 1/2. So 2 minus 1/2 is going to be 4 minus 1, which is 3 over 2. X to the power of 3 over 2 over 2. And then we're going to have 2x to the power of 3 over 2 plus the root of x times the e to the power of x. Okay, so we can simplify even further. We can combine these two since they have the same exponent. We're going to have to find the least common denominator here. So we're going to have y prime is equal to e to the x over 2 root x. And then we're going to multiply at least this right term by 2. So we'll multiply the top and bottom by 2. So we're going to have, let me just do this in blue real quick, plus x to the power of 3 over 2 plus 4x to the power of 3 over 2 over 2, and then plus the root of x times e to the power of x. And now we'll combine the numerator. Those are the like terms there. So we're going to have y prime is equal to e to the power of x over 2 root x. And then plus, and this is going to be 5x to the power of 3 over 2 over 2 plus the root of x times e to the power of x. So you can leave it like this, or you can change this second term so where you could have that root radical or radical symbol. So we have 2 root x over here plus 5 times the root of x cubed over 2 plus the root of x times e to the power of x. Either one of these two could be your final answer. All right, let's do a little bit of an easier one here. We just have this final one. We're going to have y equals to 3 over x over 1 plus 5x squared. We're going to have to use the quotient rule. Let me color code that. Let's put it in green. We're going to have the derivative of two functions being divided by f of x divided by g of x is going to equal to, we always write down our g of x first for the quotient rule, f prime of x minus f of x times the g prime of x over g of x squared. All right, so now let's go ahead and identify what my f of x is going to be. That's going to be 3x, and my g of x is going to equal to 1 plus 5x squared. Right now, we just have to substitute these into the rule and take the prime, or take the derivative. So we're going to have g of x first. We're going to have, let's write this down as y prime is equal to 1 plus 5x squared times 3 of x prime minus 3 times x. I keep saying 3 of x. It should be 3 times x, or just 3x. And then 1 plus 5x squared prime over 1 plus 5x squared and then squared. I am so tired. You have no idea. I've been doing this for so many days for you guys. So many x to the power of, or so many e to the power of something. It's kind of crazy. Like literally losing my voice. But anyways, let's do this. Thank God this is the final one. I'm not doing any more today. I may just do some on my own, but no more videos. It's very time consuming, but let's continue here. Let's have y prime is equal to, I'm going to move down now. We have y prime is equal to 1 plus 5x squared, and then the derivative of 3x is just 3, minus 3x, and then the derivative of 1 plus 5x squared is going to be just 10x over 1 plus 5x squared squared. All right, y prime is equal to, we'll distribute the 3 to the 2 terms over here. We're going to have 3 times 5x squared, which is 15x squared, and then 3 times 1, which is just going to be plus 3, minus 30x squared, when we multiply 3x and 10x, and we're going to put that over 1 plus 5x squared and then squared. Let's move it over here on the right instead of going down. We're going to have y prime now is equal to, we can combine like terms. We can have negative 15x squared. When we combine the 15x squared minus the 30x squared, we get the negative 15x squared, and then plus 3 over 1 plus 5x squared and then squared.